Knowing now how to inspect data in Pandas, let's discuss exploratory data analysis, or EDA. We'll apply EDA visually first. We'll consider Fisher's iris flower data. There are 150 observations with 4 measurements from each. There are also 3 distinct flower species. We start with importing pandas and matplotlib.pyplot. We load the data frame and examine it with head. First, let's draw some data with the data frame plot method. We can specify particular column names for the X and Y axes. The result is not all that useful because, by default, plot creates a line plot. For this unordered 4-dimensional data set, a line plot doesn't make a lot of sense. We'll try again, this time specifying kind equals scatter. Let's also label the axes with units of measurement. The scatter plot is better. We'll see later how to distinguish the different species. Individual variable distributions are likely more informative than plotting 2 variables against each other. For instance, specifying kind equals box for, say, the sepal length makes a box plot. The resulting box plot shows the range, the minimum and maximum values, with the whiskers, the interquartile range with the box edges, and the median inside. We'll define these terms clearly later. Another common plotting tool for EDA is a histogram. Here we use kind equals hist. Recall that histograms show frequencies of measurements counted within certain bins or intervals. The result approximates a probability distribution function, or PDF, of the sepal lengths of all the iris flowers. It could be bell-shaped, but it's hard to tell with bins this wide. We can redraw the histogram to get a better sense of the data. Other hist arguments can be passed using the data frame plot interface. For instance, bins is the number of intervals to use in building the histogram. Range gives the extremes of the bins. Normed tells whether to rescale counts to add to 1. Cumulative tells whether to draw the histogram or its cumulative distribution function. More on this shortly. In fact, any matplotlib options can be specified using keyword arguments with plot. Using more keyword options improves the histogram. Here, we specify 30 bins and a range from 4 to 8 and a normed histogram. The customized histogram shows at least 3 distinct peaks in the distribution of sepal lengths. This suggests groups or subpopulations in the data. Another useful plot is the cumulative distribution function, or CDF, computed by adding up the areas of the rectangles under a normalized histogram. CDFs are used to compute the probability of observing a value in a given range, for instance, a sepal width between 2 and 4 centimeters. This is easy to plot with the data frame plot method. Intuitively, the CDF evaluated at, say, sepal length 5 centimeters returns the probability of observing a flower with sepal length up to 5 centimeters. A CDF is often a somewhat smooth curve, increasing from 0 to 1. One warning, at present there are 3 different data frame plotting idioms in pandas. For instance, we can use iris.plot, kind equals hist, or iris.plot.hist with the same syntax for arguments. There is also iris.hist. The syntax has defaults that's slightly different in the latter call. These variants work for hist, scatter, box, and related plot functions. Check the documentation for details. That's enough on Visual EDA for now. It's your turn to try some exercises on your own. Plots are useful, but it's also useful to have quantitative results. Remember, a statistic is a single number that summarizes a numerical data set. We can use the method describe to list summary statistics of the numerical columns of the iris data frame. The output of describe includes counts, means, standard deviations, minima, first quartiles, medians, third quartiles, and maxima from all the numerical columns of the data frame. Let's learn what these statistics mean in detail. The count method returns the number of non-null entries in a given numerical column. The series method count returns a scalar integer. The data frame method count returns a series of counts computed over each column. The mean method computes an average of a series and the average of data frames column-wise, ignoring null entries. All series and data frame statistical methods ignore null entries. This is particularly important to ensure summary statistics like averages are not diluted by null entries. The SDD method computes the standard deviation of the non-null entries of a series. Remember, if the mean measures the tendency to a central value of a measurement, the standard deviation measures its spread. For instance, with a bell curve distribution, the mean is roughly at the middle and the standard deviation is roughly the width of the bell curve. The mean is not the only measure of centrality used in statistics. The median method computes the median of a series. Here, the median sepal width 3.0 centimeters tells us 75 of the 150 observations have sepal width smaller than 3.0 centimeters, and the other 75 has sepal widths larger than 3.0 centimeters. Similar interpretations apply to the other columns. A median is a special example of a quantile. If Q is a number between 0 and 1, the Qth quantile of a data set is a numerical value that splits the data into two sets, one with the fraction Q of smaller observations and the other with larger observations. Colloquially, quantiles are called percentiles, using percentages between 0 and 100 rather than fractions between 0 and 1. The median, then, is the 0.5 quantile or 50th percentile of a dataset, as verified using methods median and quantile Q with Q equals 0.5. The quantile method computes the median by default. Given a fraction Q, it returns the Qth quantile. The quantile method also accepts a list or array of values between 0 and 1. So for instance, using Q equals 0.25, 0.75 as a list, with quantile Q returns the interquartile range, or IQR, between the 1/4 and 3/4 quantiles. Again, we see the IQR for the petal length is between 1.6 centimeters and 5.1 centimeters, telling us half the data collected lies in this range. The range is the interval between the smallest and largest observations. These are given by the min and max methods respectively. Notice these two methods also return values for the species column, notably the first and last strings in the columns when sorted in alphabetical order. Remember, we can use the plot method with kind equals box to draw box plots. The plot shows the range and interquartile ranges graphically. You can read off the minimum, the 1/4 quartile, the median, the 3/4 quartile, and the maximum for all columns of the data frame. The box plot uses exactly the same data as reported by Describe. Notice the quartiles are reported as percentiles by Describe. Now that you understand what these statistics are, you can do some statistical EDA on your own in the exercises.